Hey guys, welcome to my channel. So in this tutorial we will be evaluating the integral of this trig function 1 all over 2 plus 2 sine x plus cosine x dx. So how do you evaluate this the integral of this trig function? So we can use the Weierstrass substitution for this kind of trig function. This is called the Weierstrass substitution. Weierstrass substitution. Weierstrass substitution is used to turn a very complex trig function into a very simple rational function that can easily be factored out using partial fractions or polynomial long division. So if you ever encounter a very complex integral of a trig function that is very difficult to integrate, one thing that comes to mind is to use the Weierstrass substitution, which will help you break down this complex trig function into a seemingly easy integral of a rational function, which can easily be integrated using partial fractions, polynomial long divisions, or other known methods. So let's see how the Weierstrass substitution works and how it can turn this complex trig function into a very simple rational function that can easily be integrated. So let's do that. So first, Weierstrass is using the substitution t equal to tan of x over 2 and sine of x equal to 2t over 1 plus t squared. Cosine of x is equals to 1 minus t squared over 1 plus t squared, and then dx is equals to 2 over 1 plus t squared dt. This is the Weierstrass substitution. So using the substitution t is equals to tan of the angle x over 2, we can find an expression for sine of x in terms of t, cosine of x in terms of t, and dx in terms of t. I made a video about this, the proof of this. So if you haven't watched that video, make sure to watch that video before watching this video, so you can understand the intuition behind these proofs. While sine of x, cosine of x, and dx are expressed in terms of t. So with that, we can use these expressions for these trig identities, plug them into our integral function, and turn this integral into an integral of a rational function, which would be relatively easier to integrate than this function. So let's do that. Our integral of 1 over 2 plus 2 sine x plus cosine of x dx is equals to the integral of 1 all over 2 plus 2 sine x. What is sine of x? Sine of x is 2t over 1 plus t squared. Plus, what is cosine of x? Excuse me. Cosine of x is 1 minus t squared over 1 plus t squared times, what is dx? Dx is 2 over 1 plus t squared dt. So we can simplify this function. That will be the integral of 1 all over, this one can be written as 2 times 1 plus t squared over 1 plus t squared. That is just multiplying the denominator and the numerator by 1 plus t squared. Plus, this one is 2 times 2t over 1 plus t squared plus 1 minus t squared over 1 plus t squared times 2 over 1 plus t squared dt. This can be simplified into 1 all over. You can multiply this one out. This is 2 plus 2t squared over 1 plus t squared plus this is 4t over 1 plus t squared plus 1 minus t squared over 1 plus t squared times 2 over 1 plus t squared dt. So this simplifies to become 1 all over this one can be written as 2 plus 2t squared plus 4t plus 1 minus t squared all over 1 plus t squared times 2 over 1 plus t squared t, which further simplifies to 1 all over this is t squared plus 4t plus 3 all over 1 plus t squared. Times 2 over 1 plus t squared dt. We can flip this one, and that becomes the integral of 1 plus t squared over t squared plus, bring it closer to the integral, this becomes 1 plus t squared over t squared plus 4t plus 3 times 2 over 1 plus t squared dt. And then this cancels that, and you're left with the integral of 2 over t squared plus 4t plus 3 dt. So this is what our integral has been reduced to. So instead of integrating 1 over 2 plus 2 sine x plus cosine of x dx, which can be tricky to integrate, you can just use the Weierstrass substitution by letting t is equals to tan of the x over 2, and we are going to arrive at this simple integral of a rational function. And this one, the denominator can be factored, so we are using the substitution. So using the Weierstrass substitution, t is equals to the tan inverse, as tan of x over 2. So now instead of tackling this, we tackle this. So now how do you integrate this one? So the integral, I'll do this in yellow. So the integral of 2 over t squared plus 4t plus 3 dt can be factored. So first, let's look at the rational function first. Sorry about that. So let's look at the integral of the rational. So the rational function itself is 2 over t squared plus 4t plus 3. And this one can be written as 2. The denominator can be factored into this. That is t plus 1 times t plus 3. And that should be equal to, so using the partial fractions, we can let a plus b. So we can split this one down. So we can multiply, do cross multiplication, plus b times t plus 1 all over t plus 1 times t plus 3. So we have 2 over t plus 1 times t plus 3 is equals to, can multiply this one out. So that should be at plus 3a plus bt plus b all over t plus 1 times t plus 3. That should be equal to a plus b, that is by doing some factorization, plus 3a plus b. Those are constants, divided by t plus 1 and then t plus 3. So since the denominators are the same, the numerators must also be the same. So we have a plus b, which is the coefficient of t in the right hand side, is equals to 0. There is no coefficient of t in the left hand side, it's just a constant. Call this equation 1, and the constant term, which is 3a plus b on the right hand side, is equals to 2, which is a constant term on the left hand side. Equation 2, you can solve these two equations simultaneously. So if you solve 1 and 2 simultaneously, you are going to get a is equals to 1 and b is equals to negative 1. So 1 minus 1 is 0, and then 3 minus 1 here is 2. So these are the two values of a and b. that will satisfy these two equations. So our rational function, which is 2 over t plus 1 times t plus 3, can be factored into a over t plus 1. A is 1 over t plus 1 minus b, which is 1 over t plus 3. That is from here. So our integral of 1 over t squared plus 4t plus 3 dt can be expressed as the integral of 1 over t plus 1 minus 1 over t plus 3. Should be 2 here. dt. This can be split down into two integrals, t plus 1 dt minus the integral of 1 over t plus 3 dt. This is the natural logarithm of the absolute value of t plus 1 minus the natural logarithm of the absolute value of t plus 3. That is when you integrate them. And this further simplifies to the natural logarithm of the absolute value of t plus 1 over t plus 3. So that is when you integrate 2 over t squared plus 4t plus 3 dt. So our integral, which was the integral of 1 all over 2 plus 2 sine x plus cosine of x dx, reduced to the integral of 2 over t squared plus 4t plus 3 dt. Using the Weierstrass substitution, t is equals to tan of x over 2. So we just have to plug in t is equals to tan of x over 2 into this expression. And then our integral of 1 all over 2 plus 2 sine x plus cosine of x dx is equals to the natural logarithm of the absolute value of t plus 1. T is the tan of x over 2, which is the tan of x over 2 plus 1 all over t plus 3. T is the tan of x over 2 plus 3 plus the constant of integration. And with this we are done. So this is the value of the integral. So that is how the Weierstrass substitution works. So whenever you are given a very complex trig function to integrate, one thing that you should do, if you are finding it very difficult to integrate a trig function, then you must think of the Weierstrass substitution, which will help you break down a seemingly difficult trig function into a very simple rational function that can easily be factored out or expressed clearly using polynomial long derivation. So that is how it works. It's a very smart way of like integrating complex trig functions. So if you find this video helpful, make sure to like the video, subscribe to my channel, hit the notification bell for more content like this. Thank you so much, and I will see you in the next one.